In example 1, we need to describe the transformations on each function. Each one of these functions is going to be an exponential function, and we want to try to describe each one of the transformations. With part A, we can see x minus 2 in the exponent position right here, and that minus 2 is going to be a shift left or right. In this case, we want to do in all cases, we want to do the opposite of the number that we see. So this is going to be a shift to the right by 2. Also, we can see this minus 5 right here. That's not up in the exponent position by the x, so it's not going to be in the x direction. It's actually going to be in the y direction or the vertical direction. So that indicates a shift down by 5. Notice we do the opposite of the number that's by the x, but we don't do the opposite of the other number that's the vertical shift up or down. In this case, minus 5 means down by 5. Looking at part B, we've got a number out in front right here that's 0.5, and that number is being multiplied by 4 to the x power. So that's going to be a vertical compression. Some people also would say widen out. So this is a vertical compression by a factor of 0.5. And then the plus 2, that's being added to the entire expression. And so that's going to be a shift up 2. Notice that the plus 2 is not in the exponent position with the x. We'll switch to a different color. And we'll go with part C here. Part C, we have a negative sign out front. And then we have a plus 6 up by the x in the exponent position. So let's do the first part, the negative sign. So that negative sign is going to be a reflection over the x-axis. So it's going to be a flip. And then the plus 6, we want to shift left 6. Remember to do the opposite of the sign that's there. So in this case, the positive sign means shift to the left. If you'd like, you can try these on your own. Pause the video and then move on. I'll go through each one though with you. In the first one here, part D, we have a plus 2 and a plus 1. And you're probably noticing that I'm ignoring the base for every single one of these. Now, the base is going to be important when we graph. The base here for this one happens to be a quarter. But we're actually going to be more focused on what the transformations are without respect to the base. And when we go through a few problems, I can show that to you. So here we have addition of 2. So this will be a shift left 2. And then the plus 1 is not by the x. So that's going to be a shift up 1. With part E, we have a 5 out front. And then we have a minus 6.5 to deal with. The 5 is being multiplied by 2 to the x, and 5 is bigger than 1. So this is going to be a vertical stretch. Some people would also say narrow by a factor of 5. The minus 6.5 not being up by the x in the exponent position is going to be a vertical shift. In this case, the shift will be down 5. So you could write shift down 5. And then our last one here, part F, we have a negative 0.2. We have a minus 1 by the x and a plus 4. So this is going to incorporate a lot of what we've just been talking about. So first of all, there's a reflection over the x-axis. That's what the negative sign does. The 0.2 is in between 0 and 1. So this will be a vertical compression. The graph's going to look like it widens out a little bit by 0.2. The next piece, the minus 1, is a shift right 1. And then the plus 4 will be a shift up 4.